When I walked into that building for the first time, I realized what it really means to be in a world-class research facility. It really made me confident in the future of our university. So I want to say that I take personal credit for the name of the building because we knew that physics and astronomy would be the principal occupant of this new facility, but we also knew that there would be a series of interdisciplinary science centers that would move in, and it seemed appropriate to have the acronym PAIS because we are the highest powered Research One flagship university that is also a Hispanic serving institution. And to have the building named for the Spanish word for nation or country seemed right. That's why it's called PAIS. So UNM's Department of Physics and Astronomy has been a world leader in scholarship and education for a generation. Expertise in optics, in quantum information, in radio astronomy, in a variety of other disciplines within physics. We knew that for the next generation of scholars to carry on that tradition of excellence, we needed a 21st century building with 21st century laboratory capabilities.
The Department of Physics and Astronomy has internationally renowned research efforts in quantum information, optics, biophotonics, astrophysics, and particle physics. And lately it's been a really successful time for us. Not only do we have a beautiful new building to work and thrive in, PAIS, but this fall we have equaled our historic high for the number of faculty department. And 30% of those are women, giving us an unusually high percentage of female faculty for a department like ours. I remember hearing talk of a new building when I arrived at UNM in 1996. And in fact, discussions had been going on for several years before that. In our old building, which dated from 1952, it was becoming too much of a challenge to carry out groundbreaking laboratory physics research. To do that, you need labs with excellent temperature control, vibrational control, electromagnetic isolation, humidity control, dust control, and a roof that doesn't leak would be nice. And all of these were problems. And the poor quality of the facilities had become a deterrent for recruiting faculty and graduate students. But it would not be until 2013 when the wheels really started turning to get us to where we are today.
Well, the effort to get us into a new building goes back many years, at least 20 years. To past chairs in the department, Dan Finley, Baron Basilick were two people who really pushed the building. Baron's efforts, I think, got the ball rolling. And then when Wolfgang Rudolph came in as chair, the momentum was in our favor.
In our old building, we had very inadequate infrastructure to do high-performance research. Noisy power lines, problems with mechanical vibrations, air conditioning systems. We had to suffer from frequent shutdowns because of that, and all that changed with PAIS. So we haven't had really a lot of time to test everything because of the COVID shutdown, but what we have seen so far is very encouraging. Our lasers are a lot more stable. It's a pleasure to work in that new building, in that environment. The air conditioning works, the temperature is much more stable than in our old building.
So my role was, I was called the shepherd. So the idea is that everybody has kind of their own little space. The general contractor wants to build a building. The architect wants it to look good and be functional. The UNM just wanted to keep costs down, etc. My role was to make sure that the faculty in the physics department, at least, were represented to the architect and to the contractors, that the things that we wanted, things that we needed for our research actually came to fruition in the building.
Well, we have state-of-the-art research laboratories in the basement of PAIS, in the basement in particular laser and optics laboratories for physics and astronomy, and one lab also for a faculty member from the chemistry department. And in addition, in the basement we have the TEM microscopy suite. On other floors, we have teaching labs and laboratories for our subatomic experimenters, biophysics, and several research groups from the Interdisciplinary Science Group.
Yeah, the students enjoy it. I mean, the classes are a lot of theory, a lot of math. In the lab, they get to put their hands on actual equipment and see the physics come to life. We've had really good success with our students going on to graduate school. The undergraduate students have had a really high level of going on to graduate school in places like Caltech and Berkeley. I'm very proud of that achievement for the lab.
We have first indications that we are able now to attract top quality students. So in our first open house, where we invite potential future graduate students, we had more attendees than ever before. So that's a good sign, and we think part of the reason is our new building.
So when we first saw the plans for PAIS, we had this suite of offices for lecturers and graduate students, and there was a small area located outside for couches, for soft seating. And we took a look at that and we said, hey, this would be the perfect place for the tutoring center. So we worked with the architects and the building designers to move some of the offices down to make a larger open area in which we could have tables, we could have power strips, we could have whiteboards, and really form a perfect space for the students to interact with each other.
So now we have this beautiful new facility, PAIS, with state-of-the-art research labs. After a lot of hard work by many people, architects, engineers, construction workers, UNM's planners and facilities people, our own faculty and staff, and faculty from various departments involved in interdisciplinary science. We also have classrooms with the latest technology, lots of informal meeting space, a popular tutoring area, and a lobby that's the focal point of the building where students congregate to study together. And we're looking forward to phase 2 of the project, which will provide us with a replacement for Regener Hall, which is our aging lecture hall. And we already know that the building is starting to do its job as far as recruiting faculty and students is concerned. So we're really grateful to the student leadership of UNM for their support and the people of New Mexico who voted to fund the project. The students are going to have a wonderful time doing very, very high quality science that's going to be internationally recognized. So they're going to get an excellent training, and it's going to help them wherever they go, to Sandia, Los Alamos, or further afield. They're going to be well prepared.
Since this was probably the only large laboratory building we could build in a decade, we wanted to take advantage of this opportunity to also create opportunities for interdisciplinary science centers. So we have a Center for Quantum Information and Control that won a recent center grant in competition with folks like Caltech and Berkeley and MIT. We have a Center for Stable Isotopes that is one of the top 2 or 3 centers of its type in North America. And they're doing extraordinary research in anthropology, in biology, in chemistry, in earth and planetary sciences. The same materials and the same capabilities can be used to look at Martian meteorites and pottery shards from archaeological digs.
The idea for the co-op began about 5 years ago from UNM's Data to Knowledge conference, which brought an interdisciplinary research community together around the common interest of improving how we use the plethora of new data available on the world today to create meaningful insights and better decisions. Success going forward will increasingly rely on having strong interdisciplinary teams behind these projects. And as New Mexico's only Carnegie-designated R1 research institution, UNM rose to the challenge and began formulating a way to take this spirit of data to knowledge and use it to support efforts like this throughout the university. From here, the co-op was born. We've been lucky enough to have 7 of the most collaborative centers and labs throughout the university join us in PAIS to not only expand their capability as researchers, but to begin to create a foundation for future success within the university and beyond.
Computational Genomics and Technology Lab, and this is a lab that I typically refer to simply as the Bioinformatics Lab. And this really grew out of discussions that we've had with various faculty, particularly in the biology department, about what can we do to bring together researchers in the biology department with computational people, such as myself, to answer some of the key, most important questions in biology these days.
One of the key questions we're trying to develop right now is the new diagnostic for COVID, which is very timely given the current circumstances. We're developing new technologies and new methods for rapid sequencing of the entire coronavirus genome that can be used not just for diagnosis, but then tracing and understanding transmission and where the disease is coming from.
Our lab grew out of a long-term field research project with wild chimpanzees in Uganda. We faced a problem in that we wanted to know more about the social and ecological factors influencing animal health and physiology, so things like reproductive function, stress, and health. But we couldn't trap the chimps, we couldn't weigh them or take blood samples, so we developed lab protocols that would allow us to adapt common clinical methods for use with urine and feces. We've been doing this for over 20 years, and our lab now has a library of over 40,000 urine samples from chimps.
We are the Center for Stable Isotopes, or CSI for short, CSI New Mexico.
We have, for the first time in 60 years since these samples were returned from the moon, they've been opened this year, and we're going to analyze these pristine samples to figure out what they're made of and what the moon is made of and how it was formed.
We now really have a large group that talks about their different ideas and comes up with new research directions that we wouldn't get without being interdisciplinary.
Our lab is called the Laboratory of Magneto-Optical Spectroscopy, and in this lab we measure the optical response to small magnetic fields, and the materials we're interested in are photovoltaic materials or solar energy materials. Optical component which wiggles the polarization of the light, and then we bring it through a sample that stands in between two magnets. And then we can measure the polarization changes as it goes through. We hope that we will use these measurements to understand more about how solar energy is converted to electricity.
We also take pride in our continued success to enhance the research capabilities we have at UNM. An excellent example is our recently funded $2.5 million NSF project to acquire a state-of-the-art scanning transmission electron microscope. This new instrument is a true atomic resolution instrument with a configuration that will be the first of its kind installed anywhere in the US, putting UNM at the cutting edge of research capabilities available anywhere in the world. This instrument will enable numerous new exciting research opportunities on the UNM campus for understanding the behavior of natural and synthetic materials at a completely new level.
Quantum information science is an exploding field with lots of new opportunities for students in industry, in national laboratories, in academia, and all across many disciplines. Our lab is called the Center for Quantum Information and Control, called CQUIC. We stand on a strong foundation of 25 years of research and development here at UNM and have been one of the pioneers in quantum information science. One of the exciting things about PAIS is our Interdisciplinary Science Center, which brings together not only CQUIC, but a whole variety of other centers which can collaborate and work together across disciplines. And this is the future. PAIS is going to let us do that.
In addition to serving as the faculty coordinator for the co-op, I'm also the director of the Center for the Advancement of Spatial Informatics Research and Education, or ASPIRE, which researches novel ways to collect and analyze spatial data. Think maps, satellite and drone imagery, tweet locations, or the harvest location of a particular biological or geological sample. ASPIRE uses geographic information science, which uses the universal language of space and time as organizing principles, to integrate and analyze spatial data from most any source. The main thing that these centers and labs have in common is their extensive collaborations with individual principal investigators, centers, and labs throughout the country and the world. Because the co-op is dedicated to fostering these relationships, our space within PAIS was built specifically to bring people together in the pursuit of shared knowledge. Our conference room's walls masquerade as whiteboards, and the 4K screen with state-of-the-art AV inside the room is perfect for video conferencing to bring together extended collaborators. The co-op room can bring together large groups for one presentation or allow them to break into smaller groups, complete with multiple computer plugins and stationary as well as movable whiteboards to inspire ideas. Finally, in the visualization lab, 18 4K screens fuse into one to enable researchers to visualize big data to a level of detail only found in about 3 other places in the world. The adjoining workroom is designed for code training and breakout group work, turning the video wall next door from a research tool into a research training tool. We are incredibly excited to share this new space and this new way of thinking about research and research training with our students and faculty and our extended community, and look forward to future collaborations that not only advance UNM's standing as an R1 research institution, but make positive impacts on our community as a whole.
I was always confident that we could do this and do this well. It took a long time to finally finish the project. So I think it was more pride than wow, we did this. It was, yes, we did this. Creating the next generation of knowledgeable leaders and the next generation of innovators in science and technology is going to be a key for the state to thrive and to grow. And this building will help us do that.
We had toured the building, many times during its construction, so we got to see it going up and all the different stages. But when we moved in, it was completely different. The day I moved into my office and realized, okay, we're actually working here, it was a very, very odd feeling. It was like this building is really for us. This fabulous facility is for us. It was hard to believe. It was like, getting your dream home. And just walking around and getting a feel for the space and realizing it was all for our benefit and all the hard work that had gone into it. It was just really a wonderful feeling.